This is the nitrogen dioxide. This picture, this represents also the motivation of the city of Paris according to their report. This one comes from the Parisian Urbanism Agency, and they showed that the Boulevard Périphérique, which is the ring road of Paris, is the most polluted space in the region of Paris. So that was another motivation to apply this policy, this transportation policy. Here we took the mode shares of people commuting to work by gender from the global survey of transport made in 2020, just to show you that we are focusing on a tiny population that is commuting, and that's why it's an ongoing work. So we are thinking about how to deliver it, but the goal of this policy will be to shift from so the two modes of carpooling will be to be a driver with a passenger or to be a passenger, and will be to shift people from taking the car alone to those modes. So the modeling, the transportation model. So this one is the part that Lucas Javaudin with André de Palma are working with, is called Metropolis 2. It's a mesoscopic transport simulator that is simulating agent travel decisions. So mode choice, departure time, route choice, for example, and it's based on discrete choice theory within a dynamic framework. So for this study case, the modeling is that the transportation model will give us two sets of travel times. One made in the baseline scenario, so without the HOV lane, and one counterfactual scenario when there is the one HOV line around the ring road of Paris and one on the two parts of the motorways, and the two motorways are named A1 and A13. The transportation model allows to simulate also road congestion in both scenarios and is based on a synthetic population. So this is what we are estimating. So this is my current ongoing work. So of course, this is what I'm trying to evolve, but the current model looks like this. So it's a 4-level nested logit model that is estimated backwards. So basically, each choice is made conditional on the upper level and anticipating the lower level. So we are estimating it backward. So the first level is the no car mode choice, which is public, bike, and walk. We estimate 2 vector parameters different for men and women, because at the level above we model the collective choice of the couple. So the first choice. So I will point it if you see it. Yeah. The first choice is the choice of the woman, and the second one is the choice of the man. So for example, here, this means that both are taking the no car option. So whether public transport, walk, or bike. Here, the woman is a passenger and the man is a driver, etc. And you see that when the couple has 2 cars, 2 or more cars, they have an extra alternative, which is both can take the car alone, which is here. And then we estimate the car ownership, so they can choose to buy one car, they can choose to buy one car or not, and they can also choose to buy another car or to stay with their first car. So our motivations here is to analyze choices, so those mode choices based on the intra-household bargaining dynamics. Because I didn't mention it, but we are estimating a collective utility of the couple here. We are not taking the couple as a we are not estimating just a unitary utility of the couple, taking the household as one person. We are estimating a weighted utility, which will be weighted by the Pareto weight and then endogenous Pareto weight that will describe the decision power of both the man and the woman. So I will talk about it in the specification. Here we want to analyze the choices based on intra-household bargaining dynamics and also the impact of this transport policy on the mode choice to commute within couples. So the estimation, we are estimating it on the French National Census, the last one of 2021, to have the most recent preferences. It's not a panel data, so here it's not our problem because we are just estimating it on 1 year. For 2021, we have 260,000 couples living and working in the Paris region. And the travel times are given by the transportation model. So just to go quick on the specification, here, this is the first level. So the utility functions are described like this, which choose a polynomial of degree of 2 to model the distance when it's the bike that is chosen or walking, and the travel time when it's public transport. And we are imposing our slope at the origin to be negative because the travel time or the distance will give a disutility to the decision maker. And here is the level 1. So I was talking about the Pareto weight. So we are estimating the woman's Pareto weight. The man's is 1 minus the woman's Pareto weight. And this is the formula. We are putting some heterogeneity in it with the couple's characteristics. As you see, the constant is not identified, so the base, the reference decision power is 50-50 for both. And then what I wanted to show you is that here we are estimating the couple's utility will be a weighted utility. That the sum of the utility of the woman and the man weighted by this decision power. So the results, I will go quick on the results because it's not this which is interesting, is more than the results on the predictions on the infrastructure. So here, what I want, we normalized the effect of distance in the utility of walk to 12 euro per hour. So our utilities are we can interpret our utilities as the cost per hour. On the level 1, this one is interesting. So we can see that the value of time when driving alone for the woman is 7 euro per hour, and for the man it's 11 euros per hour, and here you can see that when the man drives, the value of time, so how a woman perceives the time of commuting to work, is increasing by 4.4%. And when the man drives, his value of time is decreasing by half. But when the woman drives, both perceived value of times are increasing. So the value of time of the woman is increasing by 20%, and the value of time of the man is multiplied by 4 almost. So and this is the Pareto weight that is estimated. But I go quick on that. Here I represented the distribution of the Pareto weights within all the couples. And you have the couples that have more than 2 cars on the upper level there. and in the middle the couples that have only one car, and here the couples that have no car. So we can see that when the couples have no car, the decision power is shifting a little bit towards the woman, and when they have 2 or more cars, it's shifting a little bit more than on the men, on the men's side. Yeah, those are the results too. So the level 2 was the choice to buy a second car or to keep the first one. Here we can see that there is some results that are expected. The reference here is to work and to live in the city, in the city of Paris, instead of in the inner ring or the outer ring. And we can see that when living in the inner ring and in the outer ring, they are more likely to buy a second car, as well as when they are working in the inner ring or in the outer ring. And the same for the choice to buy a first car or not. So we can see the same results here that are expected. So, and those are some metrics on the model. We can talk about it later if you want. So in the predictions, that will be interesting for this application. So those are the travel times. So you have 3 different modes here. So when the woman and the man are taking the car alone, carpooling when the man is a driver, and carpooling when the woman is a driver. At the left, you have the baseline scenario. At the right, you have the HOV scenario, so when the policy is implemented. So we can see that the model takes into account the congestion, because you can see that the travel time is slightly increasing in the HOV scenario when both are taking the car alone. So their travel time is slightly increasing. This is the mean travel time. And the carpooling, we can see that because this lane will be more free, so you can see that the travel time will decrease slightly also, and in this one also. So we expect from our model to increase the utility to those modes that are the carpooling modes. That's what we observed. So in the y-axis, you have the HOV scenario. On the x-axis, you have the baseline scenario. So those both modes up, they are the carpooling modes. So we can see that when the woman is a driver and the man is a passenger, or when the woman is a passenger and the man is a driver, you can see that the utility of both modes are increasing. The mode no car, so both taking the no car option is not changing, because there is nothing that changed in those both scenarios for those alternatives. And what's interesting here is that this is the congestion that is taken into account from the model. So you can see that the alternatives that contains the car alone option, you can see that the utility is slightly decreasing. Here we just note that we are taking into account everybody, so there is people that are not going into those lanes. So that's why we are slightly observing a difference. Those are the predictions, the prediction results. So we can see that here on the baseline scenario for the man and the woman, we can see that the options that we were interested in, it increased slightly the carpooling options. So couples commuting by carpooling is predicted to increase from 2.38% to 2.5%. So this represents 403 couples that will shift by another mode to the carpooling. And we can see that it slightly decreased also the car alone in both for the man and the woman. So it's from the car alone that they are shifting towards the carpooling options. But another interesting result is that here we represent the vehicle kilometers. So it's the sum of the kilometers made by each mode of the individuals. So here you can see that this blue and this pink is the man taking the car alone in the baseline scenario, and this one is the woman taking the car alone in the baseline scenario. So we can see that we are decreasing quite a lot the vehicle kilometers by these two modes, but we are increasing the vehicle kilometers from the carpooling modes. So, and when they are, that's why it's interesting to talk about to analyze couples here, because when they are carpooling, one of them has to make a detour. So this detour will slightly increase the vehicle kilometers on the road. So the key results is that we also analyzed the car ownership. There is no significant change in the car ownership on the predictions. So the BP is the Boulevard Périphérique. Vehicle kilometers by spouses alone decreased by 18%. But as we saw, the vehicle kilometers by spouses together, here in orange and in green, increased by 330%. So then that's because they are doing detours, and the mean trip length from those detours increased from 34.6 kilometers to 37.8. So at the global level, almost no impact on the vehicle kilometers, and the CO2 emissions decreased only by minus 0.05% in those predictions. Yeah, that's it. I wanted to talk about the model, but if you have some questions about the model, it's okay. But thank you.
Thank you, Youssef. Interesting work. I have one clarifying question and one other thought. Maybe I'll start with the clarifying question. When you showed the value of time of men and women of 7 and 11 euros respectively, I didn't really understand how you got to this result. Can you explain how you compute those? And the other comment is, did you look at so stop and go traffic, and when you're stuck in traffic on the périphérique, it increases a lot your emissions. Did you see any fluidification of traffic with the HOV lanes, which would then also impact the overall fuel consumption, not just the ones commuting on the HOV lane, but the ones that are supposedly less stuck in traffic in the remaining 3 lanes?
So for the first question, I will come back to the specification. So here, basically, this is how we. So you have the individual I with his gender G and his mode J. Basically what we did is that what's in here, we imposed the sign to be negative because it should decrease the utility. The more you travel, like the longer you travel, it's decreasing your utility. So this is the specification. What we did is that for the base reference, the base alternative, the reference alternative, which is walk in our model, we imposed this value to be -3. If we suppose that we walk at 4 kilometers an hour, it will give you a cost per hour by walking from 12 euros per hour. So because the other utility functions are estimated based on this one, it will allow us to interpret our utilities as cost per hour. So that's why when we go up, and this will follow us the whole decision tree, when we go up here and we are estimating the value of time by driving alone, this value will be interpretable as a cost per hour. And the second question was more related to the transportation model that I'm not involved in. But yes, he takes into account the congestion in all lanes, not on just the HOV one. So, and what was your other question?
about the emissions associated with if you have less traffic jam, less stop and go traffic, then supposedly.
But yes, that's why you saw an increase in the vehicle kilometers, but a slight decrease in CO2 emissions. So usually, if the model did not do what you said, we should have had an increase in CO2 emission, but we had a slight decrease, even though the vehicle kilometers are increasing.
Well, what I have to say is that when you look at the figure, typically CO2 emission is not the most important thing. The most important thing in pollution is the local pollution, and the local pollution has not been studied, but it would be interesting to study. But if you have to say, because there are many policies in Paris, and basically people say just to annoy the car, and annoy the car, it means that the people who are driving alone, they have more congestion and they shift to public transportation. So is it, what is your general assessment? So if this is your aim as a policymaker, okay, maybe it's a good policy, but without this little bit perverse objective, what do you say? Is it a good policy? Or because it seems to be a marginal policy, there is not much happening. Although you are a little bit unfair because a fraction, I don't know, you say, of people are not affected at all by this policy. So if it's all people in Ile-de-France, okay, very small percentage. If it is the people who are potentially affected by the policy, then you may have more action or more percentage.
Yes, I'm not saying that it's a bad policy or a good one. We are just contributing on one part of the analysis, and as I said, it's work that we started this month, and we are just looking at the be active couples. So there is a lot more people. That's why I showed you the proportion of the shares. Like we are looking at roughly 7,000 people here, and we are focusing on only the be active couples. So there is a lot more to do. I'm not telling that it's a bad or a good one. We just started. That was the first idea. There is a lot more to do, but yeah, it was just to show how we brought up the work together. Yes.
Yeah, thanks, Youssef, for a very interesting presentation. I'm doing work with Andre and Lucas on the BP, looking at metering entrances, right? So the problem is with Metropolis, there's some fluctuations. And if you're implementing a policy that's very small scale, there's a question of whether you can detect a signal against the noise. I was not given enough noise, okay. But, all right, so the first question is, are the results just for the AM?
The AM?
Yeah, the morning.
Yes.
Yeah.
He did the simulations on the peak hours of the morning, yes.
Right, because of course the PM is also relevant, and is it, or would you expect it to be the case that the mode choice in the morning will be identical for all couples in the evening? One person could drive the car back if their work hours are different. And
I didn't thought about it, but I think that when you choose a mode at the morning, it could be the same at the end of the day. Although you can also like go with public transport at the morning and carpool with a colleague or something, or maybe you can yeah. No, that's a good question.
Okay, and the second question concerns route choice. If driving on the HOV lanes is really quick, then people may want to take advantage of it by making more of their trip on the BP. So that would involve a change of route. And you could look at that, although I think it'd take quite some time.
Actually, I didn't put it there. But we had a result when it increased. I didn't put it in the last one. No, on the BP, yeah, I put it there. On the BP, the vehicle kilometer by spouse is increased a lot.
That's for the whole trip.
Yes.
Not just the section on the BP. So you could have change of
If
additional travel because two people have to get to their destinations, but it could also be a change in route.
There is.
Yeah.
Actually, if the man drives his spouse to work and then he uses the BP, he's in there. So there is we take into account like part of the trip,
Okay. Well,
not the whole trip.
I guess we're out of time, so in any case,
Yeah.
talk later.